Ever looked at pencil lead? That's graphite, carbon atoms arranged in sheets. Now imagine peeling off a single sheet just one atom thick and rolling it into a seamless tube. That's a carbon nanotube. It's made from the same carbon as diamonds and charcoal, but with a supercharged structure. How small is it? A nanotube is about 50,000 times thinner than a human hair. If you lined up thousands, they'd still be thinner than a single hair. We're talking nanoscale, 1/1000th of a meter. You need powerful electron microscopes just to see them. If a nanotube were as wide as a garden hose, your hair would be as wide as a stadium. At this scale, materials act in wild, unexpected ways. Physics and chemistry get weird. By arranging carbon atoms into tubes, we unlock new properties and possibilities. It's a tiny structure with the power to transform our world. Carbon is the ultimate shapeshifter, forming different structures called allotropes. Take diamond and graphite, both pure carbon but with totally different properties. Diamond's atoms are locked in a 3D lattice, making it super hard and clear. Graphite's atoms form flat sheets, stacked loosely, making it soft and slippery. Same atoms, different arrangement, wildly different results. Now, carbon nanotubes are like graphite's cousin. Imagine taking a single sheet of graphite, graphene, and rolling it into a tube that's a single-walled carbon nanotube, or SWCent. It's a one-atom-thick cylinder, a marvel of molecular engineering. Sometimes these tubes nest inside each other like Russian dolls. Those are multi-walled carbon nanotubes, or MWCNTs. Each layer is held together by weak forces, just like graphite's sheets. This nesting changes their properties, making them unique in the carbon family. Nanotubes combine the best of both worlds: strength, flexibility, and new possibilities. That's why they're so exciting for science and technology. What makes carbon nanotubes so special? Their superpowers. First, strength. They're about 100 times stronger than steel, but a fraction of the weight. Imagine a thread thinner than a hair, strong enough to lift a car. Next, they're excellent conductors. Depending on how they're rolled, they can act as metals or semiconductors. This could revolutionize electronics, making devices smaller, faster, and more efficient. They're also incredibly light, perfect for building strong, lightweight materials for planes, cars, and bikes. Less weight means less fuel and a greener planet. Their huge surface area, 1 gram, can cover a tennis court, makes them great for chemical reactions. This is huge for medicine batteries and fuel cells. Nanotubes are a dream material for engineers and scientists. Their unique properties open doors to innovations we're only beginning to imagine. With all these powers, carbon nanotubes are already changing the world. They're used in super strong, lightweight composites for sports gear, airplanes, and wind turbines. In electronics, nanotube transistors could make computers faster and more energy efficient. Imagine rollable phones or solar panels you can paint onto walls. But there are challenges. Making pure, high-quality nanotubes is tough and expensive. Sorting them by type and ensuring safety are big hurdles. Still, the potential is massive. Better batteries, clean water, targeted medicine, and more. Nanotubes are a platform for solving some of our biggest problems. The science is happening now, and the future looks bright. Stay tuned. This tiny technology could change everything.